Sixth graders, today we're going to learn some problem-solving strategies for problems that involve what's called overlap. An overlap is when the numbers that are given might fit into more than one category. Okay? If they could fit into more than one category, you don't know, you have to figure out how much or what that number really refers to. And one of the ways you can do that is use what's called a Venn diagram. A Venn diagram is two intersecting circles, and so the space in the middle is called the overlap. Now, there's an example in your book, and we're going to go through that together. It's on page 212. It says, the results of a survey show that 200 drivers sit in traffic driving to work. 350 sit in traffic driving home, and 50 sit in traffic driving both ways. So, two of the numbers describe a total of who does what, and one of them says that they sit in traffic both ways. So we'll put the first one in. 50 of them sit in traffic going both ways, it says. So that means that if 200 drivers sit in traffic driving to work, and 50 of them sit in traffic driving to work and driving home, that means how many sit in traffic? If there's 200 in this circle, then how many only sit in traffic driving to work?
I know.
Matt?
150.
150, right. We would find that by doing 200 minus the amount that we already have. We know that 50 sit in traffic driving to work and driving home. And so to find this number, we'd have to subtract the two. Then, it says 350 sit in traffic driving home. Again, if we already know how many sit in both, then 350 minus 50 equals 300. Okay? So if you know what's in the total circle, you have to subtract out what's in both. That's how the Venn diagram works. Okay? Now, this one's pretty simple. Let's go to one that we're going to answer some questions about. Go to page 214. Page 214. It says, commuters were asked in a survey what types of roads they travel on to work. The results of the survey show that 90 commuters use side streets, 75 use expressways, and 85 use the interstate. 15 commuters use both the side streets and expressways. 21 use both the expressways and interstate, and 11 use both the side streets and the interstate. 9 commuters use all 3 types of roads. So, at the end of the problem it says that 9 use all 3. So that's the number we should start with. Put a 9 in the middle. Okay? 9 use all 3. We know that. Then at the beginning of the problem it tells us the total in each circle. So we should put that on the outside. How many use the side streets? Go back and look at the problem. How many use the side streets? The results of the survey show that, Abby? 90 use the side streets. How many use the expressway? Look back again and see. Megan? 75. So 75 total in this circle. And how many use the interstate? Yeah?
The interstate that would be 9 plus 2 plus 2.
No, it says in the problem.
Oh,
75 use expressways and
11.
no. Olivia?
5.
85? 85. Yep. So that's the totals, okay? And we know 9 use all 3. And we know some more. We know that 15 commuters use both the side streets and expressways. So 15 use the side streets and expressways. That's how we know that there's a 6 right here. Because 6 plus 9 is 15, and that's in the intersecting circles right here. Okay? So now we can put a 6 in this space. There's 15 total that use the side streets and expressway, use both. Then it says that 21 use both the expressways and the interstate. 21 use both the expressways and the interstate. So there are 2 numbers in here for a total of 21. If we already know there's 9 in the middle, then 12 use the expressways and the interstate. 12 and 9 is 21. Okay? And then it says that 11 use both the side streets and the interstate. And so 11 minus 9 is 2. And that's how we know that the 2 goes there. Now you should be able to answer the questions. How many only use the side streets? How many only use the side streets? Peter? 73. How do you know? Right. Good. So you add 15 plus 2 is 17. 90 minus 17 is 73. Right? How would we find the number that only use the expressway then? What would that be? Trevor? Okay, so would it be 17? Would it be the ones in this circle, or would it be in this circle? This one, right, so not 17, but 27, I think you meant, right? Because 6 plus 9 is 15, plus 12 is 27. So we'd have to take away 27. And then 75 minus 27 is... Check. 48. Agree? Did you check it?
Oh, yeah.
Minus 27. And then how many in the interstate? What would we have to take away? 85 minus, Raiden?
23.
23, very good. Which equals?
42.
Close.
62.
62, very good. 62.
42.
Now, it says, how many commuters are in the survey? Well, why couldn't we just add 90 plus 75 plus 85 to answer the first question? Why did we have to get all of these numbers in order to answer the first question? Olivia?
Because you would be adding the same people multiple times.
Correct. There's overlap. So if you just added 90 plus 75 plus 85, you'd be adding people multiple times, just like Olivia said. So you have to figure out all of the individual spots, all of the individual spaces, and then add up the numbers. How many total were surveyed? So you have to add these numbers. Only one time. Add them up. I'm waiting for everyone. You got it, Armand? Circle your answer.
Alright, let's see.
Circle your answer. Okay, circle it. Circle it. Now, each of these numbers represents people in the survey. Okay? 9 people use all 3. 6 people use both of these. 12 people use both of these. 2 people use both of these. And then 73 and 48 and 62 use only one type of highway or of road. So you have to add all of the numbers in order to find the total. No? It says how many total people were surveyed.
I know.
So you can't just add these numbers. You have to add the numbers in the middle also.
Oh, yeah.
Some of you forgot to add the numbers in the middle as well.
What did you do? What did you do? Yeah, see? You're looking. Where's your mask? Cheater. Ow.
Quiet, please. Strike one. You're missing these. You're missing some numbers. Yeah. Are you listening? You're not writing down the numbers in.
Yes!
Solve it.
Matt, you don't add these totals.
I already did everything.
You don't add these totals. You don't add these, we talked about this, you don't add these totals because they include numbers that are included more than once. So you have to add each of these individual numbers.
Do I add every in the circles?
Well, that includes all of the people that were surveyed, yes. So you have to add each of the numbers in the circles to find the total. What is it? You haven't gotten it. No.
No, that was.
Oh, yeah. It's not that. 73 plus 46 plus 6 plus 9.
Yeah, that's what you do. I got to
That's not 900. Okay, so that is the question. Okay? Now for numbers 2 and 3, what you're going to do, well, number 2, it changes the numbers. So you'll be doing the same diagram, but with some different totals. Okay? But we have to go on to another type of problem. And that is when you're described, when the problem describes a map, and you have to figure out distance. So, for example, on page 212, it says some problems show direction and distance, and you should draw it out using, like creating a sketch of a map, using north and south and east and west, and then labeling how far you're going for each one. So, for example, a bus driver leaves a bus station and travels 5 miles north. Well, if you were going to map this out, you would simply need to put a starting point, and it says that it goes 5 miles north. So you draw the line and label it 5 miles. Okay? Then it says 10 miles east. So again, using the compass rose, you would draw a line that goes 10 miles east. And it's just a sketch, so you don't have to be exact. Then it says 12 miles south. And so since it's 12, you want to go past your original sketch of 5. And then it says 6 miles west. So since this is 10, we know that only part of that way is 6. So let's say that we go 6 miles this way. That means that we are a little over halfway from where we were before. And then finally, 7 miles north. So what is this distance right here? What is this distance? If this is 12 miles, and then we went 6 miles, what is this distance from here to here? Bennett?
7.
That's 7 also. So if we go from here 7 miles north, we're going to end up right there, right across from where we started, right? But how far away is this distance? How far away is that distance? Tyler?
4 miles,
4 miles. How do you know 4 miles?
because 10 minus 6 is 4.
Right, because we went 6 miles back from this point here. So that we went back and we drew a little line there. This is 6 miles from where we went back, but it was down here. And then that means that this is 4 miles.
So could you just mark 1 house instead of the 27 miles?
Well, if it's a bus that's doing this, then it's a route, right?
Well,
A
then-
bus might have to go this way in order to pick up passengers, drop off passengers, and so on. Okay?
Couldn't you just walk yourself? Like 4 miles?
Well, that depends on what it is that you're talking about. It doesn't give us any more information about why or anything like that.
It
So,
would just make more sense to walk 4 miles instead of going around 27 miles round trip.
Kate, that
Yeah,
takes
that's-
like 50
that's-
minutes.
it's not your, it doesn't say you're on the bus and you need to go here. Okay?
Well, it's Taylor's.
So you're inferring some things that the problem is not talking about. What we're learning about is that when you are when the problem is describing directions and distance, that you should map it out using a compass rose. And then label those distances to figure out and to answer some questions. Okay? So going back to page 214, number 3 describes a problem similar to that. Okay? Matt, is this about this problem? Is this about this problem? Okay, come back to, I'll look at that later. You can show me later. Look at number 3. Yes. Bob, Fran, Pat, and Nino all take the same bus to work. Bob's office is 12 blocks north of Fran's office. So if we're going to map this out, use the compass rose, label a starting point. It says Bob's office is 12 blocks north of Fran's office. So Bob's office, Fran's office. And there's a distance of 12 miles. Oh, 12 blocks. Great. Thank you.
That's a lot.
12 blocks. Okay. Then it says Pat's office is 4 blocks south of Fran's office. So Pat's office is down here. And then it says Nino's office is north of Pat's office and halfway between Bob and Pat's offices. How far is Nino's office from Bob's office? So when you finish this problem, you need to put those in and then answer those questions, okay? Now, for doing number 4 and number 5 and number 6, you are going, number 4 is kind of working backwards. That one involves a clock. We've worked backwards on problems before to figure out time. And then for 5 and 6, for 5 you have to use a Venn diagram, and for 6 you have to use a map again. Okay? So, do 2 through 6 for tomorrow. 2 through 6.
Oh, wow.